This is Chapter 4, Problem 8, and in this problem we have a plane that flies 483 kilometers east from City A to City B in 45 minutes, and then 966 kilometers south from City B to City C in 1.5 hours. As always, I'm going to start by drawing the scenario because I have a hard time envisioning this kind of thing. So here we have the east trip, and this is going to be 483 kilometers. And then we have the southern portion of the trip, so we travel down south, and that's going to be 966 kilometers. So those are our two displacement vectors. We also want to keep in mind that we're going to be taking into account the total time for the trip. Okay? Now this is pretty important. You have the first part of the trip is 45 minutes, and the second part of the trip is 1.5 hours. So 45 minutes plus 1.5 hours is the same thing as saying 2.25 hours. Everybody remember that a quarter of an hour is 15 minutes, so half an hour is obviously half of an hour, so the 30 minutes goes into the 1.5 hours to make 2, then we have 15 minutes left over, and that's 2.25 hours. I'm keeping the answer in terms of kilometers per hour because that's what the book is going to do, but you can obviously change the units into meters per second if you so feel. The first part, we're trying to find the magnitude of the displacement vector, and then we're going to find the angle. Now, in order to find the magnitude of the displacement vector, the magnitude is equal to, notice that I'm putting in those absolute value signs because that means the magnitude of the vector, and that's going to be equal to the square root. Remember, this is a triangle where we have an x component and a y component. We're going to try to find the hypotenuse, and we're going to get that by squaring the 483, or the x component, and then adding that to the square of the y component, 966, and then take the square root of that. And we're going to get that the magnitude of the displacement vector is about 991.59 kilometers. And now if we want to get the angle measurement, we're going to take the tan inverse. Remember that the tan is equal to opposite over adjacent. If we're going for the angle here, if we're going for this angle right up in here in the drawing, then that is going to be the 966 divided by the 483, and we get that the angle is equal to 63.43, and that is south of east. You're pointing east, and then the angle is opening south. For the next part, we want to find the magnitude and the direction of the average velocity. I'm going to do this part in unit vector notation just because I find it to be a little bit easier. Remember that the displacement vector in this case would be 483 I hat minus 966 j hat. And now that's all in kilometers. And then in order to get the average velocity, we need to divide that by the total time, 2.25 hours. We now, in unit vector notation, get a value of 214.67 I hat minus 429.33 j hat. And notice that the units are kilometers per hour. Kilometers in the numerator, hours in the denominator. And you'll get, if you do your a squared plus b squared equals c squared, once again using 214.67 as the x component, 429.33 j hat as the y component, you'll get that v average is equal to 480 kilometers per hour. And notice that the angle will be exactly the same as before. The angle is equal to 63.43 degrees south of east. The angle is exactly the same. The only thing that we've changed is because we are doing the average velocity, we have to divide by the total time. Now the average speed is something that you could get wrong if you're trying to do this too quickly. Remember that speed is distance over time, not displacement. So in this case we're going to have 483 plus 966, and we divide that by the 2.25 hours. And so we're going to get an average speed of 644 kilometers per hour Please note that this is just a magnitude because speed is a scalar quantity. There is no direction component. Mickey agrees as he's jumping all over me right now. Remember, guys, when we're doing like a circle problem, a circular track, if I ask you guys for the average speed for one complete lap, it would be the circumference divided by the time. If I ask you for the average velocity going around the track, then that would be 0 because the displacement would be 0. Keep that in mind. This is the kind of trick question that comes up fairly often.